In this video, we are going to do these three questions, and these three questions are collectively based on the three chapters. In fact, we'll be using the properties of similarity of triangles and tangent from same exterior point, properties of circle that radius is perpendicular to the tangent at the point of contact. We'll be also using the properties of areas of a ring, how to calculate the area of a ring, and for the area of semicircle. So let's begin with the first one. Now, in this question from the chapter circle, we are given two circles as you can see, and the radius of these two circles are mentioned as 5 and 3 centimeter. Further, we are also given the length of PQ, that's 16 centimeter, and what we have to determine over here is the length of AB. The first thing that we will do here is to join the radius with the point of contact. This is the first one, and this being the other over here. And we know the measurements of this. This is going to be 5 centimeter and this is 3 centimeter. Now we are also given the length of PQ over here. So I should write over here, we know the length of PQ as 16 centimeter. Now the first thing that we will do here is to prove these two triangles similar. One will be this. Let me highlight in the triangle here I'm talking about. The triangle over here is APC can be proved similar to triangle BQC. And that's how, because of number one, you can see that radius is perpendicular to the tangent at the point of contact. So these are 90 each. Further, we can prove these two as vertically opposite angle. So over here, I can write that the triangle APC should be similar to triangle A corresponds to B. So that's why it's BQC. And that's by A similarity. So once these triangles are similar, right? Now, next what I will do over here, I can take the length of say one of them. Let's say I took this CQ as 8, sorry, A is what I've taken. And we know the length of PQ as 16. So therefore the length of PC should be how much? 16 minus A, right? So what I did, I took this length as A, therefore the remaining length will come as what? 16 minus A. Now, since the triangles are similar, I can write their sides proportional. So I'll use the similarity corresponding sides. AP corresponds to PQ. So AP over PQ is equal to, we need PC, right? So this is last two letter, that is PC corresponds to QC. Now check if I write down the length of AP. AP is how much? AP is 5. The length of PQ is 3. PC is what? PC is 16 minus A, and QC is how much? That's 8. Now, if I do cross multiplication, what do we get here? We get 5 times A is equal to 48 minus 3 times A. That results to give you 8A as how much? 48. So we get A as how much? Yeah, that's A as 6. We got A as 6 centimeter. Now, if I got the length of AS6, let me write down over here. I can write this length as, we got this as 6 centimeter. This is 6 is what we got. So therefore, this is 16 minus A. 16 minus A is how much? That's 10. So now we have the length of this also as 10 centimeter. But then we had to get the length of AB. So I can split AB as two parts. One, I take it as X. This part I take it X, and BC as Y. And as I said, the radius is perpendicular to the tangent at the point of contact. We can use Pythagoras relation to obtain the length of is X first. So I can see that from here, that is X square plus 5 square is equal to 10 square. Yeah, the square of hypotenuse is equal to sum of the squares of other two sides. So this is 100 minus 25. So x out comes out to be under root 75, which can be reduced and written as 5 root 3 centimeter. So we got the length of We got the length of x. And similarly, we can also obtain the length of y over here. So we can say here too, that's y square plus 3 square is equal to 6 square. So y square comes out to be what? 36 minus 9. So y will be under root 27. So y should result to give you how much? 3 root 3 centimeter. Yeah. Now once we got this, we have to get the length of AC, and we can see from the figure AC is equal to x plus y, and x is 5 root 3 and this is 3 root 3. Am I right? Yeah, it should be 75, 25 into 3. That's right. So therefore, we can say this is coming as 8 root 3. So the length of AC comes out to be 8 root 3. That's how we will do this question. Now, in this question, we have to find the length of AB. Well, this is the length of AB. And we are given the area of the shaded region. The shaded region is this, and its area is given as 7 pi square. So what I'll do, I'll first mark the center as O and join with A to be the outer radius. And let's say I take this as capital R. And similarly, you are going to join with P to get the inner radius. I took it as small r over here. Now, what do we know that area of a ring is given over here, and its formula is area of the outer circle minus the area of the inner circle. And we can equate with 7 as 7 pi, in fact, which is given. So check here, if I take pi common over here, that results to give you this as 7 pi. We can cancel this pi. So we got one relation between the radii as this. Now check, we have to get the length of AB. So what we know that radius is perpendicular to the tangent at the point of contact. So this angle is going to be 90 degree, right? This is 90 degree. So the thing is that we can see that AB is what? AB is the tangent to the circle for the inner radius, right? So with respect to the inner circle, what you can see that radius is perpendicular to the tangent at the point of contact. So since AP is that's AP OP. That's since OP is perpendicular to AB, what we can say? We can say that we can apply Pythagoras, right? We can apply Pythagoras theorem in this triangle, right? This triangle. So this is, I should name the triangle over here. Let's see if I write in triangle AOP, we note that the square of the hypotenuse, which is capital R square, is equal to sum of the squares of other sides, that is R square minus AP square, sorry, plus AP square. Now check here, if I transpose this R square to the left hand side, we get small r, capital R square minus small r square is equal to AP square. Now, we know the value of this, right? We know the value of capital R square minus small r square from here. So what I can do over here, I can directly replace this value over here with 7. So we got the length of AP square as 7, right? So that means that the length of AP will be what? Under root 7. Now look for the outer circle, right? For outer circle, AB is a chord, right? For outer circle, AB is a chord and OP is perpendicular drawn from the center. So we know that perpendicular drawn from the center bisects the chord. So we can say that here the length of AP should be equal to BP, or we may further say that AB will be twice of AP, right? The reason over here, as I said, for the outer circle, AB is a chord and OP is perpendicular, and perpendicular drawn from the center bisects the chord. So now I can get the length of AB, which is twice of AP. Well, AP is under root 7, so that results to give you 2 root 7 centimeter. Yeah, that's what we needed to find out. We'll say this is 2 root 7 centimeter. In this question, we have to find the area of the semicircle. The semicircle area we have to find out. And further, we are given the length of DC. This length DC is given 1 centimeter and EC as 2 centimeter. So clearly we can see over here AB is a tangent and even A is also a tangent to this semicircle, E being the point of contact. So what I'm going to do in the first go, I'm going to join this radius with the point of contact with the center. And I can mark this as R over here. That's the radius. Well, from the figure, we can see that even OC is also the radius. Now, next, what we know that radius is perpendicular to the tangent at the point of contact. So this angle has to be 90 degree, right? So now we can apply Pythagoras relation in this triangle, right? The triangle is this only. So let me write down the reason over here. First, I should write OE is perpendicular to AC. And the reason for that is going to be the radius is perpendicular to the tangent at the point of contact. That's what we should write down. Next, we can apply Pythagoras relation in this triangle. So the triangle over here is triangle OEC. So we have hypotenuse is what? The side opposite to 90 degrees. So clearly OC is the hypotenuse. So OC square is equal to OE square plus the other side, that is EC square. OC from the figure, you can see that OC is R plus 1, right? OC is R plus 1. So this is going to be R plus 1 whole square. The length of O is how much? R. So that is R square plus EC. And EC is how much? EC is going to be 2. That's 2 square. So I can expand this. A square plus 2 times AB plus B square is equal to R square plus 4. Now this get cancelled over here. So that is 2R is equal to 4 minus 1, which is 3. That implies the radius as how much? 3 over 2. Now once we got the radius, we can find the area, and the area of semicircle is what? Half pi R square. So this is half times pi. Say if I replace pi with 22 over 7 into R square. Square of this is going to be 9 over 4. This can be simplified a bit. I can reduce this by 11 times. That should give you how much? 11 into 9 is 99 over 28 centimeters square. Right. This would be the area of this triangle, semicircle. Now, what came to my mind, can we find the area of this triangle as well? That is this triangle, right? Can we find the area of triangle? Let's check. First, we have already got the radius, right? So let's figure out how can we get the area of this triangle. Let's erase this portion. Now I'm going to find the area of this triangle as well. That's an extended part. Let's say area of triangle ABC was also be the part of this question, is the part of the question. So first part we have done the radius. Let's figure out how can we get the area of this triangle. So we know it's a right angle triangle as radius is perpendicular to the tangent at the point of contact. What in case if I take AB as x from tangent from same exterior point, even this is x. So I can write AB is equal to AE and say x, and the reason is tangent from same exterior point. Now, in order to get the area of this triangle, I need the base and the altitude, right? The base has to be this. This is base and the altitude x. So at the end, we have to get the value of x. So now check here. Check here. What is BC? BC should be how much? R plus R, right? R plus R plus 1, that is 2R plus 1. So the length of BC, 2 times R is how much? Multiplying 2 is 3. 3 plus 1. So the length of BC we got as 4 centimeter. The length of BC we got. And the length of AC, which is the hypotenuse, is x plus 2 as per the figure. That's the length of AC. and AB is x. AB is x. Now I'm going to use the Pythagoras relation over here. So the triangle over here is triangle ABC. So in this triangle ABC, we can say the square of the hypotenuse, which is AC square, is equal to AB square plus BC square. AC, which is x plus 2 whole square, AB, AB is x, and BC is 4, right? So this is 4 square. So now if I do expansion of this, this is a square plus 2 times AB is what? 4x plus b square, that is 2 square, which is 4. On the other side, this is x square plus 4 square is 16. Now this x square get cancelled, so we have 4x as how much? 16 minus 4, which is 12. That results to give you x as how much? 3. We got x as 3. So once we get the length of x over here, x here, which is 3 centimeter, we can find the area, and that's how possible, because now we can say area of a triangle is half base into height. So if I use this space only, that is area of this triangle is half times base, and base is BC over here. Base is BC, which is 4, and altitude is what? AB, right? Altitude is this AB, and we have the length of AB calculated as this is AB. As you can see, AB is 3. So we can cancel this, and we get the result as 3 into 2, that is 6 centimeter square, right? So we got the area of this triangle as well as 6 centimeters square.